Hello guys, we're going to have a treatment of the course Kirchoff's laws. So Kirchoff's laws. So Kirchoff's laws. So we're going to see the Kirchoff's laws, and then we're going to undertake an experiment to verify the Kirchoff's laws. So first, let us see the theory behind the Kirchoff's laws. So in the Kirchoff's laws, we have one, the junction rule, and we have two, the closed loop rule. So these are the two rules in the Kirchoff's laws, the junction rule and the closed loop rule. So when we say the junction rule, this is what we mean. So this is a point where you have different currents coming into the point and some current leaving the point. So let's see the points that are coming. So let's say this is I1, this is I2, this is I3, I4, and this is I5. So you can see that I1 and I3 are coming to the point, are coming into the point, and then I2, I4, and I5 are leaving the point, So in the Kirchoff's, this is the junction rule. So let me just write here junction rule. So this is a junction rule. So in the junction rule, what it says is that the summation of current that is entering the point, that is, let's say, input, should be equal to the summation of the current that is leaving the point, let's say output. Okay, so that's the Kirchoff's current rule. So the sum of current that is entering the point must be equal to the sum of current that is leaving the point. All right. So having known the Kirchoff's current rule, let us go to the closed loop rule. Okay, so let's say this is voltage V. So this is R1, this is R2. So this is a closed loop rule. What it says is that the sum of voltages, so the summation of voltages in a loop should be equals to 0. So the summation of voltages in this loop should be equals to 0. So those are the two main Kirchoff's rules that we have to know. Let us see this brief example. So this is a closed loop. Okay, so let's see how we can be able to verify the closed loop rule. All right, so this is a closed loop, and here is negative, here is positive. because it's a single loop, the current that will be going through will be the same current. So that is I. And I'll do this one to signify that it is a closed loop. Alright. So here, 12 volts, okay, or let's say 12, is equals to 10I. So we're going to have it 12 is equals to 10I plus 20I. Because it's a closed loop, so the same current is going to go through all of them. Alright. So here we're going to have, so 12 volts. So let me say 12 is equals to 30I. Okay, in that case, I'm going to have here over 30. Okay, so my I is going to be, I is equals to 0.4 amps. Okay, so we got I to be 0.4 amps. Now let us verify the rule. Let us calculate for the voltage drop across each of the resistors. Okay, so the voltage drop across the 10 ohm is going to be voltage drop across each resistor. Okay, so across the 10 ohm, we're going to have 10 into 0.4. Which is going to give us 4 volts. So the voltage drop here is 4 volts. If we subtract 4 from the 12, then we're going to have 8 volts here. Now let's calculate for the voltage drop across the 20 ohm resistor. Is going to be 8 volts. So the voltage drop across here is 8 volts. So if you take this 8 away from this 8, you're going to have 0 volts. So if here is 0 volts, there is no there is no load over here. So there is no loss in voltage here. So here also be 0 volts. Okay. So now you can see that the sum of the voltages in the loop is 0, as stated by the closed loop rule. All right. So now there is another way that you can also analyze your circuit. Let's look at that one also. Okay, so here is 12 volts. Here is 12 volts. So here is negative, here is positive. Okay, so whenever we are moving from the negative to the positive, our voltage is what? Increasing, because we are moving from a negative to positive. So our voltage is what? Increasing. Okay, so here we will take our voltage to be positive. So positive 12. Okay, so let's show our current by this way. This is our current I. Okay, let's see, here is our 10 ohm, here is our 20 ohm, and this is our loop. Okay, so now here, whenever our voltage or our current is going this way, this place will become positive, here become negative, here become positive, here become what? Negative. Okay, so because what happens is that the voltage will flow from the higher density place to the lower density. From the higher potential to the lower potential. Okay. It will flow from the higher potential to the lower potential. So here will be positive, and then here will become negative. Okay. All right. So now, whenever you have whenever we are moving in the same direction as the current, you will have a voltage drop. That one will give it a negative sign. So here, because I am moving the same direction as the current, so there will be a voltage drop across this 10 ohm. So I'll have a negative sign as 10I. when I come here also, I am moving in the same direction, because you can see that the current will be coming here. It's the same I, because it's the same loop. So now I am still moving in the same direction as as my current. So my voltage will be negative. Okay, so I'll have minus 20 watt I. So the sum of the voltages in the loop must be what? 0. So I'll put 0 here. Alright. So if you can check, this one is just the same thing as we did previously. If you can check these two, they are the same. Alright. So we just have to solve this one. So we will have 12 minus 30I is equals to 0. Okay. So you have 12 over 30 is equals to 30I over 30. Okay, which is equals to 0.4, okay, as before. So you can also use this method. All right, thank you.